For 7.2, we're going to do solving exponential functions. So we've looked at the graphs of an exponential function and what it is. Now we're going to start with solving. And if you notice, I'm calling this solving exponential equations and inequalities part 1, because these ones will be ones where we do not need a calculator to solve. We will look further in the chapter at ones where we need a calculator to solve. So let's get started. What we're going to do are the odds together, and then I'll have you try the evens on your own. So for these ones, when we're looking at exponential expressions or inequalities, our goal is to have the bases to be the same, okay? That's our goal. If the bases are the same, then simply the exponents will just be set equal to each other. So if we look at number 1, the bases are already the same. They're both base 4s. So for these to be equivalent statements, we have a power of 5 on the left, so the overall power on the right must also be 5. So since the bases are the same, I just set the exponents equal to each other, and I solve. So subtract 1, we get 4, and divide by 2, and we get x equals 2. Simple as that. We don't have to do any checks because exponents can be any numbers we want, right? We can plug in positives, negatives, fractions, it doesn't matter there. So the only check you need to do is just to double check your calculations. Okay, but what happens if those bases are not the same? Like in 2 and 3 and 4, 5, and 6. We need to try to make them the same. So again, these are part of the non-calculator parts because although the bases aren't the same, we can rewrite them to be the same. So if we look here, we have a 3 as a base on the left-hand side on number 3. On the right, we have 1/9. My goal is to write one of these bases as either 3 or as a 9. So I know 9 is the same thing as 3 squared. So I can rewrite this 9. However, it's 1/9, remember. So instead of 3 squared, to have a fraction like that, we would need a negative exponent. So I'm going to rewrite this problem so that the left-hand side stays the same, but the right-hand side will simply be 3 to the negative second. This is an equivalent statement. I didn't change the equality of anything, right? 1/9 and 3 to the negative second are the same thing. Now that I rewrote it, the bases are the same, so now I can simply set my exponents equal to each other. So 2x minus 1 equals negative 2. We will add 1. That will give me negative 1, and now divide by 2. So x equals negative 1/2. Again, no need to check for domain errors. Okay, number 5, let's do that. So we're going to work with the same process, but just remember here we have an inequality. So the only thing you need to remember are inequality rules. When we multiply, divide by negative, watch that symbol. So this time we have a 16 and an 8. So the question is, can I write 16 as 8 to some power? No, I can't, right? We can write it as 8 times 2, but that's not 8 to some power. Could I write 8 as 16 to some power? No. So now I have to think about, okay, well, is there a number that both 16 and 8 I can use as a base that base to a power can equal? So some people may think about a 4. Well, 16 is 4 squared, but can 8 be written as 4 to some power? No. What can be? And that's the number 2. 16 is the same thing as 2 to the 4th. Don't forget, we still have the exponent of 2x minus 3. So this is an equivalent statement to this left-hand side. 2 to the 4th is 16. And then we have our less than, and 8 is the same thing as 2 to the 3rd. So now we have the same basis. So I can set my exponents equal to each other. Well, to do so, I'm first going to use my power rule. So again, this is really saying 2 to the 8x minus 12. Remember, power to a power, we multiply. So distribute 8x and minus 12. And then less than 2 to the 3rd. So again, those bases are the same. So I'm going to now set my exponents not equal to each other, but with our inequality. So 8x minus 12 is less than 3. And remember to use whatever the inequality is. If it's pointing to the left-hand side, make sure it's still pointing to the left-hand side. So now we'll solve that. We get 8x is less than 15, and divide by 8. We don't have to worry about flipping our symbol since it's a positive. So we get x is less than 15/8. Remember, for inequalities, since that's multiple solutions, we usually write that in set notation. Okay, so you try numbers 2, 4, and 6. Try rewriting those bases with the same base. Maybe you only have to change one side. Maybe you have to change both sides. Okay, now let's look at writing an exponential function given ordered pairs. Okay, so our general exponential function is in the form of a times b to the x. Okay, remember that base for each parent function changes. So that base could be a 2, it could be a 3, it could be a 1/2, etc. And then we have our power is our x, our variable, and then there's usually some sort of coefficient out front. Now that coefficient could be 1, it could be, so you don't see anything, it could just be a negative, so forth. But our general function here will be f of x equals ab to the x. So when I want to write that general function, I need to solve for a and b. Okay, so that's our goal, looking for a and b. Since I'm looking for two variables, usually that means I need two equations. So the good news is here we have a couple of points. This 0, 3 represents an x and a y, and this represents an x and a y. So for my first equation that I'm going to have, I'm going to plug in our first ordered pair, 0 and 3. So 3 will go in for f of x, which really means y. I don't know a and I don't know b, but I do know x is 0. Now, this is super handy that they gave me the ordered pair with an x of 0, because what is b to the 0 power? Anything to the 0 power is 1. So what happens right there is that our b is canceled, and we can find right there and then that a equals 3. Well, how am I going to go find b? So now what I'm going to do is I'm going to use the second ordered pair for our second equation. So I'll plug in 81 for f of x, or for y. This time around, we know a is 3, so I'll plug in 3 for a. We don't know b, but my x value of that ordered pair is 3. So now I'm going to solve this. What we need to make sure we're careful with is how to get our variable alone. Remember, exponents are most attached, so least attached would be the coefficient out front. So I'm going to divide by 3, the coefficient. This gives me 27 equals b cubed. And how do I undo b cubed? We take the cube root, which this is super nice. That gives us 3. So both a and b are 3. With that being said, what does that mean the equation is? Again, our general form is y equals ab to the x. So I'm going to plug in for a and b. So y equals 3 times 3 to the x. Notice I am not multiplying 3 times 3. I'm not writing 27. That's because order of operations, powers always go first. We cannot actually do 3 to the x. So therefore I can't multiply. So here is my final answer. Okay? Let's try to do the same thing given a word problem. So I'm going to start this off for you and see if you can finish it. This question is really identical to what we just did above. I know it doesn't look like it, but it is. So it says Kristen starts an experiment with 7,500 bacteria cells, and after 4 hours, there's 23,000 cells. What we're going to do here to figure out my function is just create 2 sets of ordered pairs. And I have those right here in front of me. If I'm starting an experiment, that means my time is 0. So at the beginning, 0 time, there was 7,500 bacteria. Now after 4 hours, so now my time is 4, there was 23,000 bacteria. So what I want you to do is, using these ordered pairs, come up with an equation. So go solve for A and B like we did above, come up with your equation. Then use that equation for part B to plug in 12. Again, you can round. It's okay to use a calculator for this problem. Give that one a shot. All right, now we have another type of a word problem. We're going to be looking at word problems throughout and then devote a specific day to sum them all up. So one formula that you want to start to have memorized. We looked at a growth and decay one in our last section. Another formula you want to have memorized is compound interest. Okay, so compound interest, we are talking about money, obviously, being compounded and growing. So we have something that's regular compound and we have something called compound continuous. Right now we're focusing on regular compound. And compound interest can be compounded at different times. You may have where your money is compounded weekly. You could have it be monthly, annually, semi-annually, okay? Daily, if you're lucky. And what that means is that the interest rate is affected about that amount many times. So if I say semi-annually, that only means twice, 2 times a year. If I say monthly, then that would be 12 times a year. So if we look at these variables, A is going to be my amount, P is the initial amount, so what we're sort of investing, we're starting with. R is our rate, N is our times compounded. So again, if it was monthly, N would be 12. If it was daily, N would be 365. Time is however long we're going to have this money in our account. So if I want to know after 12 years, then 12 is my time, not my N. Okay, so let's take a look at this example and then I'll have you finish solving it. So an investment pays 4.2% annual interest, compounded monthly. So here's my interest and we're compounding monthly. I have 2,500 invested. What will the balance be after 15 years? Round to the nearest cent. So let's put some key information here. What does this 4.2 represent? That's my rate. However, remember with rates, we write rates as decimals. So that's 0.042. Next, we have compounded monthly. That represents my N value. So if I'm compounded monthly, that means N equals 12. 2,500 was invested. That's my principal, my initial amount. What will the balance be after 15 years? So my time is 15. And I'm looking for A. So now I pop that into the equation. So A equals the initial amount times 1 plus my rate of 0.042 all over N, which is 12, to the NT, 12 times 15. So what I want you to try to practice doing using a calculator is plugging these values in to make sure A, you know how to use the calculator, and B, that you're using it properly with the order of operations. So go ahead, finish that one off, try to round to the nearest cent, and we will see how you do.